Welcome. In this lesson, we're going to learn to do very simple dilations. Dilations are basically increasing or decreasing the size of a shape, but we also do it about a center, which is very important that it also actually moves the figure, not only shrinks it. So as an example, I'm going to do this one here. And I want you to realize that what we're going to do is we're going to take every point. Let's take this point S that has an X value of 8 and a Y value of 8. And what we do is we do 1/4 of both those values. So 1/4 of 8 is 2, and 1/4 of 8 is 2. So this point right here is going to be the new point for S. I do the same thing for R. R has an X value of 4 and a Y value of 8, and I do 1/4 of those. 1/4 of 4 is going to be 1, and 1/4 of 8 is 2. So this point right here is going to be my new R value. This is my S value. And now I do the same thing for T. T has an X value of 8 and a Y value of -4. So if I do 1/4 of 8, that's going to be 2, and 1/4 of -4 is -1. This point right here is going to be my new T value. Again, what's important is you notice it actually moves it also closer to the center. All of these are going to be moved either closer to the center or further away if the dilation is an increase in scale factor. We'll do some more so you get a good feel for this. So again, I'm just going to do it a lot quicker this time. I'm just going to take my E value and I'm going to do 3 times as big, which means both the X and the Y are 3 times as big. Since one's -3 and the other one's +3, I'm going to go out to -9 and 9, which is that point right there. That's my new E. It's 3 times as far out in the same direction. Or X is 3 times as big, Y is 3 times as big. So here, my X is going to be 3 times as big, which puts me out to 9. My Y is 3 times as big, which puts me out to -9. And again, 3 and 3 means I'm going to be out to 9 and -9, just like that. So it's a lot bigger about the origin. We're always doing it about the origin. Here we're doing a half. So again, R is going to be half as close to the y-axis and half as close to the x-axis. And then S is going to be half as close and half as close. And this point down here is going to be half as close. So it's at 10, so it will be at -5. And there is my new shrunken figure by a half. Again, 3 times as big. So my X is going to be 3 times as big, and my Y is going to be 3 times as big. X was 1, so I went out to 3. Y was 2, so I went out to 6. Again, 1 times -1 will be, 3 times -1 will be -3, and 3 times -3 will be -9. I'm way down here. And then this one, it's going to be 3 times as far out as -3, so it's going to be out to -9 as well. And again, hopefully you can see that that's just an increase in size about the origin. If you have any questions on how to do this, please bring them to class. Just remember, take both the X and the Y for each value and double it. The X and the Y, double it. The X and the Y, double it. I'm going to double X and I'm going to double Y. I'm going to double X, which puts me out to -6, and I'm going to double Y, which puts me up to 4. I'm going to double X, which puts me out to -10, and double Y, which puts me down to -10. Again, not -10, -4. That looked a little off. I could see that there we go, much better. So just remember, double the X, double the Y for every single point.